Hi everyone, welcome to our channel. You are welcome once again. We've been discussing operation with surds, and today we are going to be looking at surds rationalization. So how do we rationalize a given surd, or how is rationalization of surds being done? Alright, so just to give us in a very layman understanding, when you are talking about rationalization of a surd, we said before that surds are roots of irrational numbers that cannot be, that the exact value cannot be determined. Okay, so now we are trying to make sure that we have a denominator. You see, the target is the denominator. Whenever you are rationalizing surd, we are saying the rationalization of surd is concerned with the process of removing irrational number from the denominator. So the target, the target thing we are looking at is to remove the irrational from the denominator. So just like we see here, when we say irrational, we can see root 3. Root 3 is, you see, is irrational. So we are trying to remove this particular irrational number from the denominator. So just to use a simple man language, when you have successfully rationalized, you will discover that you will not see anything like a root at the denominator any longer. You're not going to see anything like that. So what you will just see pure constants. You will see that this aspect of it is actually it's not going to work any longer. So this is important. I want us to please bear this in mind. Very, very important as we progress. All right. So how do we do this? In the case of this, we simply say, what can I do to this root 3 that is going to make you disappear? All right. So you are going to simply just say, okay, if this is 2, 5 root 3. Now, I know that the only thing I can do to root 3 that can cancel it out is by multiplying it by root 3. Because I know that root 3 multiplied by root 3 is going to give me root 9. And root 9 eventually is going to turn to 3. You see? Okay, which this is work. So what do I do? You simply multiply both the numerator and the denominator by that. Because you can't multiply only the denominator, you are going to alter the expression given. So, but root 3 over root 3 is as good as saying you are multiplying this expression by 1. Because root 3 divided by root 3 can 1 here, root 3 1 here, which is 1 over 1, which is 1. So it's like you are saying 2, 5, root 3 multiplied by 1. So that's what you do. But you have a target. Your target is to eliminate this. And you are able to see that when you do that, you are going to have this irrational number removed. All right. So when we do this, we are going to have 2 root 3 at the numerator. Then we are going to have 5 into root 3 multiplied by root 3. Okay, this is very important. We must know this. So we have 2 root 3 into 5 times. Of course, this is going to give us root 9. Let's show the steps first. Then as we go subsequently, we can be skipping some little details. All right, so we have this. I believe we are understanding this. This is going to give us 2 root 3 divided by 15. Okay, and this is going to be the answer. So your target is you are not interested in, because you can still see the root. The irrational number has now jumped, is now at the numerator, right? Yeah, but the target is the denominator. Don't forget that is our denominator that we are going to ensure. So if you have actually rationalized, the first place your examiner will go and check is the denominator. They want to see am I still having irrational numbers at the denominator? If yes, then the examiner can say, this person have not successfully rationalized this. But if he could see that, the irrational number has been removed, all right, that's good, then you begin to now examine your processes and the way you have solved the problem to now see how you can put award marks. All right, so let's look at another question. Now, this is another question. We have to evaluate 3 divided by root 3 plus 2, or plus root 2 rather. All right, so whenever we have a question like this, the first thing you also check, don't forget that we have to rationalize. You see, sometimes they will not tell you rationalize, just like the way this examiner just say evaluate. But from our experience, you will know that, okay, what the examiner is simply trying to say is that please rationalize this denominator. I don't want to see irrational numbers at this denominator. Please kindly remove them. All right, so how do we remove denominators that has a function, a mathematical function like positive that we have here? So we normally rationalize them by multiplying them by their conjugate. I don't know, can you still remember conjugate? Please, we actually treated conjugates in one of our videos. Please do try and go and search for that video and watch it from the beginning again, so that you can see what conjugate is all about. Just a refresher course. For example, when we are finding conjugate of any expression, we simply look at the sign in between the two irrational surds. So you see the sign in between this one is positive. So the conjugate of this is going to be root 3 minus root 2. You just take the opposite sign of the sign in between them, and that's the conjugate. All right. So what do I do now? I will multiply both the numerator and the denominator by the conjugate of the denominator. So that's what you do. So I'm saying that you multiply. We are going to multiply the numerator and the denominator by the conjugates of the denominator. Okay, so this is very important. This, we need to actually know this. So I'm writing it out this way so that we can look at it at a glance very quickly. So what am I doing there? I'm going to say, okay, I have root 3 added to root 2. So I'm going to multiply this by root 3 minus root 2 divided by root 3 minus root 2. You see, this is like over 1, just like what I've showed us earlier. So this is what we are going to do. So if we do that properly, what we are going to have 3 into root 3 minus root 2, then divided by, we have root 3 plus root 2, then we have root 3 minus root 2. Now, you don't need to stress yourself. You remember, if you can recall, let's quickly recall difference of 2 squares. If you please go back to the previous video and watch that, because there is this particular one we did that we said that whenever you have, from difference of 2 squares, for example, if I have this equals to this, it's going to give me x plus y, x minus y. I believe we still know this. All right. So we see the same thing, but the sign in between them differ. So we simply square each of them. Just pick the first one, square it, minus the other one, square it. All right. So that's simply what you are going to do in this. If you apply that rule very well. So we are going to have root 3 minus root 2. Then we have divided by. So when we apply the rule of difference of 2 square, we are going to be root 3 square minus root 2 square. So can you see that? So if that is done, we are going to have 3 into, okay, there's a bracket here, 3 minus root 2. Okay. So just like I told us earlier that when you have a square root and you square it again, the answer is going to be what is inside this bracket. And I was proving to us why it is so. We actually apply indices to this. What this one, indices says x raised to the power of 1 over 2 is going to be the square root of x, all raised to the power of 1. You remember this? All right. So if that's the case, if I have root 3 all squared, so I'm simply saying 3 raised to the power of 1 over 2, then times 2 again. So these 2 we cancel these 2. Then you have 3 over 1, which is 3. All right. So that's what we are going to have. We are going to have 3 minus 2. Okay. And we are going to have 3 into the bracket of 3 minus root 2, all divided by 1, because this is going to give you 1. All right. So you can leave your answer like this, or you can also open up and allow 3 to multiply to open the to remove the bracket. You are going to have it as 3 root 3 minus 3 root 2. And this is going to be the answer. You see that the denominator has been, actually dealt with from a denominator that is having irrational numbers to eventually something that is no longer having even a denominator any longer. So this is a good way of rationalizing. I told us, don't forget, whenever you are rationalizing, your target is the denominator. You are trying as much as possible to remove all irrational numbers from the denominator. I believe we enjoyed this video, and I believe we have the understanding. So let's look at some more questions so that we can know how to handle. I believe the more we solve, the more we'll be able to gain mastery. All right. Thanks for watching. Let's see another question as we progress further. All right. So this question 2 under rationalization of surds. This question simply is saying that we should simplify 1 divided by 1 minus root 3 all squared. Okay. Okay, so how do we handle this? This is very important. I really love this kind of question because it's going to give us an idea on how to, or help us to perfect how we can multiply things. Just for a refresher purpose, remember when you have x plus y all squared, what do we say? It's simply as saying x plus y multiplied by another x plus y. It is what you are going to have. Okay, so in the same way it's going to, this is not a difference of 2 squares. Please don't let us make that mistake and say, this difference of 2 squares, and let me don't know. Not at all. Please don't let us do that mistake and say, no, but the ideal thing is just for you to expand those 2 brackets. So you're simply saying you have double bracket like this, multiplying one another. Okay, so we have it doubled. Okay, so that's exactly what we are going to do. So what do? We expand this bracket. So we have 1 into 1 minus root 3. Then again, minus root 3 is also going to multiply 1 minus root 3. Okay, so when we do this, we are going to have 1 minus root 3. Okay, then minus root 3 is going to also multiply what we have inside this bracket. So we are going to have minus root 3. Multiplied, minus times minus is going to give us plus. Then root 3 times root 3 is going to give us root 9. Root 9, which is 3. I believe we are understanding that. All right, so we collect like terms. We have 1 plus 3 because those 2 are constants. So I have 4. Then minus root 3 minus root 3 will give me minus 2 root 3. This is very important. We must be able to do this. Is very, very important. I think we should also put an emphasis on that, so that I believe a lot of students used to get confused when they get to expressions like this. They begin to wonder. Some can even say is 0. I've had students say is 0. No. You see, a good way of looking at this is you can factorize, bring out root 3. Let's see. If you bring out root 3, you are going to be left with minus 1 minus 1. You see, because root 3 minus root 3 divided by root 3 is going to give you minus 1, and the same thing here. So minus 1 minus 1, of course, minus 1 minus 1 is going to give you minus 2. So which is negative 2 root 3. So please, you have to, this factorization will also give you a clearer view of what is going on. And also, you can also look at it in another way. You see, I know sometimes when I want to explain to students, I tell them, see, this root you are seeing, just look at it as x. You see, if you say minus x minus x, because they are used to algebra, so they know that minus x minus x is equals to minus 2x. You see, in this case where your x is equals to root 3. So if you change it back, you are going to have minus 2 root 3. and you refer it back. So we have some a lot of ways. The more we solve, the more we actually gain the knowledge. All right. So what does this imply? Now it means that the solution is simply 1 divided by 4 minus 2 root 3. So this is it. This is what we are asked to now simplify. So how do we simplify this? We multiply the numerator and the denominator by the conjugate of the denominator. We multiply the numerator and the denominator by the conjugate of the denominator. So what is the conjugate of this denominator? I believe we can do that. The conjugate of this denominator now is going to be 4 plus 2 root 3. I told us it's just the sign in between, then you are going to change. All right. So if that is taken, so let's just let me have a way here. All right. So let's now solve the problem. So we have 1 divided by the whole of this denominator now from our simplification is now 4. 4 minus. Let me start that again. It's going to be 1 divided by 4 minus 2 root 3. Okay, so what we do to rationalize now, we multiply this one by 4 plus 2 root 3. Then also we multiply this one by 4 plus 2 root 3. Okay, so when we do that properly, we are going to have 4 plus 2 root 3 all divided by, I told us this one is usually a difference of 2 squares. So you don't need to bother yourself on how do I expand this, how do I do that. Just know that whenever you are rationalizing with conjugate like this, usually the denominator is usually difference of 2 squares. You can see it obviously. So what you need to do is just to say 4 plus 2 root 3. All right. So you take one of them, which is 4 square. Okay. Minus the other one, which is 2 root 3 all squared. All right. So this is what you are going to do. All right. So when we do that, we are going to have 4 plus 2 root 3 divided by, this is going to give us 16, of course. This is going to be, now in this case, you are going to have, in indices, there's what we call product power law. So you have 2 root 3, then is squared. In other words, we have 2 root 3 multiplying another 2 root 3. So you see, that's simply, so 2 is going to multiply 2, root 3 is going to multiply root 3. So 2 times 2 is going to give you 4. Root 3 times root 3 is going to give you root 9, and which is 4 times 3. I believe we understand that. So please, let's put that in our mind. It's going to give us 12. Okay, so I can now successfully put 12 here. So that's the expression of this. Don't forget that root 2 root 3 all square is going to be 2 root 3 multiplied by another 2 root 3. All right, so 2 times 2 multiply each other. Root 3 times root 3 we multiply. I told you like terms we multiply one another. Only like terms we multiply one another. So we have 2 times 2, which are like terms. They multiply, they gave us 4. Root 3 times root 3, like terms. They also gave us root 9. And root 9 is 3. All right, which is 4 times 3. All right, so finally we are going to have 4 plus 2 root 3 over, if you take 12 from 16, you'll be left with 4. Okay. Now, I can also go further, since this is, I can say 4 over 4 plus 2 root 3 over 4. I can, depending on how the examiner wants it. So I can also, just because I'm seeing some factors that are common, so I can just do this, so that I can have 1 plus, then at the numerator now I have root 3, and at the denominator I have 2. All right, so you can leave your answer like this also. So it can be this or further simplify down to that particular answer. I believe we are enjoying this video, and I believe we understand how this particular problem is being solved. Thanks for watching. We are also going to take some few more questions, so that I believe by the time we do about 5 or 6 questions, we'll have have a good understanding on how this is being done. All right, so let's look at another question. So as we progress further, in order for us to gain mastery on how to do the rationalization of sorts, I believe the more you solve, the more you understand, and the more you gain expertise, the more you gain mastery, and the more you know how to apply knowledge. The more you expose yourself to different kind of questions, the more experience you gather. That's just mathematics for you. All right, so let's see another question very quickly as we proceed. All right, this is question 3. The question says 2 plus root 3 divided by root 2 minus root 3. So we have to simplify. So how do we simplify this? I told us you just check the denominator, then you now find the conjugate of the denominator, and you now use that conjugate to multiply the numerator and the denominator. The target is to remove irrational numbers from the denominator. All right, so what is going to be the conjugate of root 2 minus root 3? So what's going to be the conjugate? It's going to simply be equal to what? It's going to be equal to root 2 plus root 3. So you see, this is going to be the conjugate. So I told us it's just the sign in between, then you change, and that gives you their conjugate. All right, so let's quickly, without wasting much time, let's just go back straight to the question. We have root 3 divided by root 2 minus root 3. So what do? We multiply both the numerator and the denominator by the conjugate of the denominator. So which is going to be 2 plus root 3. We also have 2 plus root 3. Okay, so at the numerator now we have two brackets being formed there. We have these two multiplying each other. Very similar. You see the brackets are identical, but their signs are not different, unlike what we have at the denominator. In the denominator we have root 2 minus root 3. Then we have also sorry, this is root 2. The conjugate is this. All right, so we should have it this way. This should be having root. So they are not the same. Yeah, they are actually not the same. So we have root 2 plus root 3. Okay, so yeah, that's that. All right, so what do we do next? We simply let's deal with the numerator first. All right, the numerator is going to be that this 2 is going to multiply this bracket, plus root 3 is also going to multiply this bracket. Okay, so if that is done, let's just open it. I have 2 into root 2 plus root 3. Okay, then I'm through with that bracket. So I'm through with 2. I'm bringing in root 3 also to multiply the same bracket. Okay, now everything divided by, of course, this is difference of 2 squares. I told us you don't need to waste time. Just have root 2 square minus, of course, root 3. Somebody may be asking, will it always be minus? Yes. The sign between them will always be minus because we are applying the principle of difference of 2 squares. So when we say difference, so we are talking about subtraction. So it will always be minus, irrespective of the sign that they are having. Once you see that okay, they are the same. This is root 2. This is root 2. This is negative. This is positive. This is root 3. This is root 3. Oh, beautiful. You just apply your principle of difference of 2 squares, which is x minus y into x plus y. So you see, when you do this, that's what you continually to do even in this particular problem. All right, so let's open this. Don't forget that constants cannot go and multiply a rational number like this. It's just going to multiply the coefficient. In this case, the coefficient of root 2 here is 1. So it's going to be 2 times 1. It's going to give us 2 root 2. Then the same thing is applicable to this. This is also going to give us 2 root 3. Okay. Now here also we are going to have plus. Now we can see these two are like terms. We can have we can see root 3 and we can see root 2. So root 3 times root 2. We have root 3 multiplied by root 2. From our law, is simply saying root 3 times 2, which is root 6. I believe we still remember that. So this is going to give us root 6. Then again, we have root 3 multiplied by root 3. We have addition. Root 3 is also multiplying root 3. This is going to give us root 9, which is going to be 3. All right, because square root of 9 is 3. So we have here to be 3. Okay, divided by, if we do this, we are going to have 2 minus, if we do this, we are going to have 3. I believe we understand why it's so. I've actually showed us in our previous video. The example we did previously. We saw that I also show you that it's actually application of indices, the law of indices that we they actually applied here that made this root and this square to go. All right. Please, you can still go back and check the solutions that we had in the previous question that we solved. All right. So the next thing to do here is to collect the like terms. How do we collect like terms? You look at surds that are similar, and obviously none of the surds here are similar. I can see 2 root 2. I can see 2 root 3. I can see root 6 and plus 3. So they are not actually similar. They are not similar at all. They are not similar at all. So this is what we have. So meaning there is nothing we can do than to just rewrite it. We have 2 sorry, excuse me, root 2 plus 2 root 3 plus root 6 plus 3 divided by -1, because 2 minus 3 is going to give us -1. All right, so when we do that, it's simply negative. The minus sign is going to come, and I'm going to have something like this: 2 root 3 plus root 6 plus root 3. Okay, so when you use the minus to go through them, because you have negative 2 root to multiply, this sign also will change to 2 root 3. So also will change to negative root 6, and this is changed to -3. Okay, so there's nothing we can do. We can't simplify for that, because we can't find any basic we can't have any similar surds there. None of these surds are similar, so this is how we have to leave our answer. Okay, I believe we understand this problem, the way it's being solved. I think we are actually coping and catching up with the speed. So let's take about 3 or 4 more questions, so that we can, I believe by the time we solve all those, we are going to have gained mastery on some of the specifics, that we ought to do. All right, thanks for watching. Let's just go to question 4 now, as we round up this particular session. All right, this is question 4. In this question, we are asked to express 14 plus 8 root 60 divided by 6 root 20 minus 10 root 12 in a form a root 5 plus b root 3, where a and b are rational numbers. All right, so just like what we used to do, we first of all try to convert them, to make them be in their basic forms. Okay, so very quickly, I can see 8. We have 8 root 60. Of course, 8 root 60 is going to give us 8. I think by now we should be gaining mastery. Okay, and this one is going to give us 8 times square root of 4 multiplied by square root of 15. Okay, the time is coming that I believe we are not going to be showing all these details. We just write the answer, because I believe everybody would have been able to, we know what to do. So this is just how this is done. Square root of 4 is 2, and 8 times 2 is 16, then root 15. All right, so we also have 6 root 20. We want to take this one to its basic form. It's going to be 6 multiplied by 4 times 5 which is 6 multiplied by square root of 4 multiplied by square root of 5. All right, this is going to be 6 times 2 times root 5. And this is going to give us 12 root 5. Okay, then the last one that we want to take to its basic form is 10 root 12. And this is going to give us 10 multiplied by square root of 4 times 3, which is going to be 20 root 3. Okay, if that is done properly, square root of 4 is 2. When it comes here, it multiplied out of 20. Then we have root 3 left. All right, so what do we do now? Let's substitute. Let's put all this back into what the examiner gave us. All right, so in this question we have 14 to be added to. So let's put it. We have 8 root 60 now is now 16 root 15. Okay, divided by 6 root 20 now is now 12 root 5 minus 10 root 12 now is now 20 root 3. Okay, from our expression. So the next thing to do is to multiply the numerator and the denominator by the conjugate of the denominator. So the conjugate of this denominator is going to be 12 excuse me, root 5 added to 20 root 3. Okay, this is going to be what the conjugate is. All right, so having known this, I believe we still understand how to find conjugate. It's simply just changing the sign in between the two expressions. So what we now do, we multiply this, the numerator and the denominator by it. So we have 12 root 5 plus 20 root 3, okay, divided by the same thing, 12 root 5 plus 20 root 3. Okay, so these are going to multiply this. So if this is done properly, we are going to have two things on the at the numerator. We have bracket open 14 plus 16 root 15. Okay, then we also have 12 root 5 plus 20 root 3. Okay, divided by then at the denominator side we have 12 root 5 minus 20 root 3. Okay, then we also have 12 root 5 plus 20 root 3. Okay, so this is what we have. So what do we do now? We open these brackets. We simply open it. So 14 is going to multiply 12 root 5, and it's also going to multiply 20 root 3. The same thing applicable to 16 root 15. It's going to multiply everything inside this bracket. All right, so let's just expand. Let's bring it one after the other. Let's express our intention. So we have 12 root 5 plus 20 root 3. Okay, then plus we have 16 root 15 is multiplying 12 root 5 plus 20 root 3. Okay, this is what we are going to have. Then at the denominator, of course, this is difference of two squares. So we are going to have 12 root 5 minus 20 root 3 all squared. All right, I believe we are getting this. This is very, very important for us to know. Let's have a fresh page so that we should be able to express this properly. All right, this is, I believe all the steps we are taking, we are following. So let's have a page. Let's have a fresh page. Then let's rewrite what we have there. So we have 14 into the bracket of that's 12. Okay, 12 root 5 plus 20 root 3. Okay, then we have added to positive 16 root 15 into the same thing, which is 12 root 5 plus 20 root 3. Okay. I believe I've written the correct thing. All right. So we have, and at the denominator, of course, we have the conjugate being squared. Okay. So we have 12 root 5 squared minus, then we have 20 root 3 squared. Yeah, I believe this is what we have. We have 14, 12 root 5 plus 20 root 3. And we have 16 root 15 into bracket of 12 root 5 plus 20 root 3. Then 12 divided by 12 root 5 all squared, 20 root 3 all squared. So it's 20 root 3 all squared. All right. So what do we do now? We begin to expand the brackets. All right. So constant, this coefficient, we multiply, like terms, we multiply one another, just like we've been saying. Okay. So if we do this, it's going to be 14 times 12. Okay, so we have 14 multiplied by 12. That's giving us 168. So we are having 168 root 5. Then plus 20 multiplied by 14 again, that's 280. That's going to give us 280 root 3. Okay, we are done with that. Then plus, we are going to have 16 multiplied by 12. 16 multiplied by 12. So we have 16 times 12. That's 192. Okay, so we have 192. This 15, root 15, we also multiply root 5. Root 15, we multiply root 5. So 15 times 5 is 75. Okay, that's going to give us 75. So we have root 75. Okay, then plus this 16 also is going to multiply this 20. So we have 16 multiplied by 20. That's 320. We have 320. 320. Then root 15 is also going to multiply root 3. Root 15 is going to multiply root 3. That's root 45. Okay. Root 45. Okay, so everything divided by, of course, this is going to give you 144 because you are going to square that, multiply by 5, minus, this one is going to give you 400 multiplied by 3, 20 squared. Just like I told us, it's going to be 20 squared and 3 squared. So if you have 20 root 3 all squared, it's same thing as saying 20 root 3 multiplied by another 20 root 3. So 20 will multiply 20, root 3 will multiply root 3. So if you do 20 times 20, giving you 400. So you see, you have going to have 400 multiplied by 3 because root 3 times root 3 is going to give you root 9, which is 3. So we have 1200. All right. So this is what we are going to have here. Then 144 also, 144 multiplied by 144 multiplied by 5 is going to give us 720. Okay. So we are having 720. I believe we are understanding this. So what we need to do now is to collect like terms at the numerator. Then I can see some that are no longer in their perfect, in their basic form. So I need to quickly do that. So I have 168 root 5 plus 280 root 3 plus 192. This is 25 times 3. Then plus 320. This is 25. No, this is 9 times 5. Let's just make this is 9 times 5. Okay, this is 9 times 5. All right, everything divided by 720 minus 200. That's what we are able to have here. So we have 168 root 5 plus 280 root 3 plus 192 times, if you bring out 5 will come out and it will mean 3, plus 320, if you bring out 3 here, times 3 times root 5, that's what you are going to have. Okay, all divided by 1200. I will say minus 1200. Okay, we have negative 480. Okay, so minus 480. Okay, so we still have to do so many of these things. We still have to push it more further. Don't forget the form the examiner asks us to leave this problem. All right, so it's only these two that have not agreed. So 192 times 5. 192 times 5. That's 960. Okay, so I can have 960 there. All right, so I have 168 root 5 plus 280 root 3 plus 960 root 3. Yeah, I think my calculator gave me 960. Okay, then this is 96 plus 3 times 3, that's 9 times 6, that's 6. So this is another 960 root 5. Everything divided by negative 480. Okay, can we see like terms? Yes, I can see like terms. See similar sorts. I can see 280 root 3, 960 root 3. I can see 168 root 5, 919 this root 960 root 5. All right, so all these ones we are going to bring them together and then simplify them accordingly. I believe we are enjoying this video. We are going to progress and continue even as we solve this. All right, so without wasting time, I believe we are coping. We are seeing the solutions and everybody is flowing along. All right, so let's quickly now do this. Let's try and collect the like terms. So we do what we call the collect like terms. Collect the like terms. All right, so when we collect the like terms, then we are going to now simplify further on what we should do. All right, so let's just have a fresh page as we progress. All right, so let's just go straight ahead. Let me recopy this. Okay, so what where we stopped, we had 16. Yeah, we had 16. Let me just recopy it to this page so that we can now progress. So we have 168 root 5 added to 280, added to 280 root 3. Okay, then added to, we're able to have 960 root 3, then added to another 960 root 5. Okay, then everything was we added to be divided by negative 480. Okay, so now what do we do? I told you that we were saying the last we said we should collect like terms. So how do we collect like terms? We look at sorts that are similar, then we bring them together. How do we know sorts that are similar? We simply check those that have the same root form. I can see root 5, root 5. So those two are similar. So I bring them together. I have 168 root 5 added to 960 root 5, then plus 280 root 3 plus 960 root 3. Okay, so I've been able to bring together the similar sorts, everything divided by negative 480. All right, so what do we do? surds that are similar can be added and they can be subtracted from one another. So, but in this case, is a negative, positive sign that is in between them. So we are going to do 168 plus 960. Let me draw on my calculator. So I have 168 added to 960. Okay, that's 1128. So we have 1128. 1128 root 5. Just take one of the roots. Then plus. Then we're also going to do 960 plus 280. 960 plus 280. Okay, that's 1240 now. So we have 1240. Root 3. All divided by minus 480. Yeah, but don't forget that the examiner told us that they want it to be in a form. They gave us a form. They want it to be a root 5 added to b root 3. I believe you still remember this. Yeah, this is what the examiner says they want it to be. All right, and they say where a and b are rational numbers. All right, so what we simply need to do is to divide each of these expression by the denominator. So we have this, just divide it individually, divided by 480 plus 1240 root 3 divided by negative 480. So it's possible you may not have 480 may not be able to divide this. So, but you just have to find a way of reducing to the lowest term. Okay, so you have to find a way of reducing to lowest. So this is the form we want it to take. You see, for obviously we can see that we have our root 5 and our root 3, which is what is peculiar. We can see them clearly. So is the numerator, we just the coefficient, we just need to tidy up our a and our b. All right, so in this case we are having minus 1128 divided by 480 root 5, then plus 1, that's 1240 divided by, now this is negative 480, so that sign in between is going to change, root 3. Okay, so what am I going to write? I'm going to get minus 1128 root 5 divided by 480 minus this divided by 480 root 3. All right, so we can simplify this. Let's just look at factors that can actually divide. Can 4 go? This divided by 4. Okay, it's giving me 310. All right. All right, it's giving me 310. So if I say 12, 40, right, if I divide by 48, can 48 go? Let's see. Oh, no, it cannot. All right, so, but can 8 go in 1240 divided by 8? I'm trying to find factors. Yeah, 8 can go. But can 8 go in 48? All right, so it can also go. So, in this case, I can see 8 here is 6. 8 in this 1240. So we have 1240 divided by 8. Okay, that's 115. Okay, so we have 115 here. 115. Then what about here? Can 8 also do the wonder? Let's see. See a factor. In that particular side, we have 1128 divided by 8. Yeah, 8 can also go. All right, so that's good. That's 141. All right, so 8 here is giving us 141. While 8 here is giving us 60. Should be 60, not 6. Because, because of this 0. Okay, so that's 60. So what do we have now? That was going to be negative 140 divided by 60. root 5, then negative, no, sorry, this is 141. Why this is 115 divided by 60, root 3. Okay, so our A is negative 141 over 60, and our B is negative 115 over 60. So this we are able to see this. However, this is the form the examiner say he wants it to take. So only that our A and B happens to be a fraction. It happens to be a fraction. All right, I believe we understand this particular solution. Let's take another one. Let's look at another one very quickly. Look at this. In this case, we are to, this is question 5. And here we are to also, it says is equals to A plus B root C. Find the values of the constant A, B, and C. All right. Simply saying, this is another way to ask us to rationalize. But this is in a fraction form. So what do? We have 1 divided by root 7 minus 1 minus 1 over, we have root 7 minus 3. So the first thing to do here, you have to find the LCM. The LCM is going to be root 7 minus 1. Of course, the two of them. Then root 7 minus 3. So if this divided by this will remain root 7 minus 3. So here we are going to have root 7 minus 3. Then minus, we are going to have root 7 minus 1. Okay, so this is what we are going to have. And when we do this properly, we are going to have root 7 minus 3 minus root 7 plus 1 at the numerator. If we allow this negative sign to open this bracket, what we are going to have then at the denominator, we are going to have root 7 minus 1 multiplying root 7 minus 3. All right, so you see, this is root 7 plus root 7 minus root 7. That's going to give us 0. Plus root 7 minus root 7 is going to give us 0. So please, let's take note. Plus root 7 minus root 7 is going to give us 0. Just like you are saying minus plus 2 minus 2. Minus 2 is going to be 0. So just is something similar. So what we are left with at the numerator is minus 3 plus 1, which is going to be negative 2. All right, divided by root 7 minus 1 into root 7 minus 3. All right, so we are going to expand this bracket. We are going to expand it to see what we are going to do. So we have minus 2 into, I have root 7 is going to multiply root 7 minus 3. Then minus 1 is also going to multiply root 7 minus 3. So this is at the denominator side. So we have minus 2, of course, divided by root 7 times root 7, that's 7. Then minus 3 root 7. Okay. Then minus 1 times root 7 is going to give us minus root 7. Then plus 3. All right. So we collect like terms. Those that are similar, we bring them together. I can see minus 3 root 7 minus root 7. So they are similar. All right. So I have minus 3 root 7 minus root 7. See, their short form is the same. Then plus 7 plus 3. Okay, this is going to give me negative 2 into minus 3 root 7 minus 7 is going to give us minus 4 root 7. Minus 4 root 7, then plus 10. Plus 10. Are we understanding this? You see, there are some things I think we need to just, for the sake of those of us that are trying to understand this, especially how did I do this area? What are those things I look at for before I actually brought this matter up? So I will have to I will have to show us properly. I have to show us certain things that we need to know, especially when it comes to issues like this. All right. So I believe we understood how I got this line. This very one is by multiplying root 7. Multiply by root 7, that's root 49. Root 49 is 7. Then root 7 multiplied by negative 3 is going to give us negative root 7. Okay. Then minus 1 multiplied by root 7 is going to give us negative root 7. And negative 1 multiplied by negative 3 is going to give us positive 3. All right. So this is how we got this. Now, what we do is to collect like terms, that is surds that are similar. We bring them together. So minus 3 root 7 minus 7 minus root 7 they are similar because their root form is the same. So this is like 1. There is like as if you are saying minus 3 root 7. So I told you the coefficient we handle one another. So it's like this. Just look at what I did here. Minus 3 root 7 minus root 7. Root 7 is common, so bring out root 7. When you bring out root 7, what will be left here will be minus 3, and what will be left here is minus 1. You see? So if you have root 7 into minus 3 minus 1 is minus 4. You see, it's as if you are hoeing. You know, we normally say negative means you are hoeing in our, in our elementary math. Our teacher used to use that illustration for us. All right, so this is product. This is, you are multiplying. Root 7 multiplied by minus 4 is going to give you minus 4 root 7. So this is how I got this minus 4 root 7. Then I have 7 plus 3, which is 10. Okay, 7 plus 3, which is 10. So I don't want this negative to be out. So I brought 10 forward. I pushed this one in. So that's how I got 10 minus 4 root 7. It's the same thing. These two are the same. I just play with the signs. I don't want the negative to show like this. Though there's nothing wrong. If you want to go like that way, fine. But I said that to just tidy it up. Let positive 7 be front. Then minus 4 root 7 to be behind. So the sign is still remain the same. The plus is still plus here, and the minus is still minus the way it was before. All right, so let's go to another fresh page and wrap this up. I believe we are enjoying this video and we are understanding what we are doing. All right, so let's quickly just round this up and get the final answer as expected of us. Okay, so what do we have? Let me just transfer the solution here. So what we got was negative 2 divided by 10 minus 4 root 7. Okay, so what do we now do? We are going to rationalize the denominator. And how do we do that? By multiplying both the numerator and the denominator by the conjugate of the denominator. So what's going to be the conjugate? The conjugate of 10 minus 4 root 7. And of course, this is going to give us 10 plus 4 root 7. Okay, so if we do that, we are going to have minus 2 divided by 10 minus 4 root 7. Then multiply by 10 plus 4 root 7 divided by 10 plus 4 root 7. All right, so if we do that, we are going to have here negative 2 into 10 plus 4 root 7, okay, divided by, we're going to have 10 negative 4 root 7, and we are going to have 10 plus 4 root 7. Okay, so what do? We can open this up and have negative 20 negative 8 root 7. While at the denominator we are going to have difference of two squares, which is 10 square minus 4 root 7 squared. Right, so what are we going to do next? We are going to just simplify this. we have minus 20 minus 8 root 7 divided by, this is going to give us 100 minus, this is going to give us 16 times 7. I believe we are understanding what I'm doing. This is going to now be 20 minus 8 root 7 divided by 100 minus, so let's quickly do this. 16 times 7, 16 times 7, that's 112. So we have 112. Okay, so this is going to give us minus 20 minus 8 root 7 divided by negative 12. Okay, all right. So when we do this, because we are told the form they want it to take, the examiner says they want it to be in the form of a plus b root c, and we are asked to find the constants. If you remember what the question told us to do, the question asks us to do this. You see, the question, we are given this, and we are to find the values of the constants a, b, and c. So that's what we are doing now. So what we need to do now is to simply just use this that particular denominator to divide each of them. So we have 20 divided by minus 12 minus 8 root 7 divided by minus 12. Of course, this one minus, we cancel this minus. 4 here is going to be 3. 4 here is going to be 5. Okay. I can also see 4 here. 4 here is going to be 2. 4 here is going to be 3. All right, so we have 5 over 3 here. This negative is going to change this sign to positive. Okay, then we have 2 root 7 divided by 3. Okay, so this is what we have. Then if we want to make it to look at this like this form that we are asked to make it, it's going to be this plus, this is going to be 2 over 3 root 7. So, and this is our final answer that we got. Our final answer is this. So our A from this expression is 5 over 3. Our B is 2 over 3. And our C is equals to 7. You see, this is what the examiner asks us to find. I believe we are getting this. I need to do something for us. I need to show us certain things on how we can multiply surds. Sometimes it can be confusing. Sometimes you don't know what and what how do I express this, how do I multiply this and this together. So let me just take time again to just illustrate certain things to us. Let this just be as we wrap it up, this is the last thing we are doing. I just discovered that there is a need for us to have an idea of what I'm talking about. So let's just look at something very important. Let me just clarify us on some areas where we may be having a little bit of confusion. So all right, so let's just look at what I'm saying. I want to just show us certain areas that I know students normally have challenges, especially when it comes to the area of this. All right, so now let me quickly just let's note certain things very important for us to note. Now let's start from saying, if for example you have something like this and it's multiplying another thing like this, maybe another expression of sort like this, how do you simplify this? How do you simplify this? So what you need to do is this. You see, we have coefficients of the irrational part of the sort. This one is irrational part. This one also is the irrational part. So we have their coefficients. So the coefficients will multiply one another. Then the irrational part will also multiply one another. So that's how it's being done. So here we are going to have 16 times 12. And at this other side, you are going to have root 15 multiplied by root 5. You see, this is what you are going to have. The coefficient or multiplying the rational part, they are multiplying one another. The irrational part is also multiplying one another. Are we following? So this is how you do this, so that you not get confused. This is the rational part, they will multiply one another. Then this is the irrational part, they will also multiply one another. So this is very important, and I want us to quickly know how to do this. All right, if we do this, so what do we get? You will discover that you are going to have 16 multiplied by 12. It's going to give you 192. All right, so you are able to have 192. All right, so then you are also going to have 15, because from the rule, if you remember the multiplication law or rule, we said that when we said the square root of PQ is the same thing as saying square root of P multiplied by the square root of Q. All right, so in the same vein, if we have 15 multiplying root 5 is the same thing as saying root 15 times 5. Did you see this? So that's how you express it. So when you do 15 times 5, it's going to give you 75. Okay, so we have 75 as this. All right, so what is going to happen is, after the rational part multiplying each other and the irrational part multiplying, you come and put it side by side like this. Okay, now I discovered that this is not in the basic form, so what do? I take it to the basic form. So this is 192 multiplied by, of course, this is going to be 25 times 3. So which is going to give me 192 multiplied by the square root of 25 multiplied by the square root of 3. If I split it again, just like the way we splitted this, so you are going to have 192 multiplied by 5 multiplied by root 3. Now you see the irrational part. Now we can see another 192 and 5. Both of them are rational, so we multiply them together. We have 192 multiplied by 5, which is a 975. 975. So we have 975 root 3. 975 root 3. So you see, this is how you can actually solve this problem. This is how you can actually solve this problem. So this is what you do whenever you have you are confronting something like this that you need to multiply. Then you just allow the rational part to multiply each other and the irrational part to also multiply each other. So another one I quickly want to show us is maybe when you have something like 4 root 7 and you have minus root 7. Okay, what you simply need to do is, you can see root 7 is common to them, so bring out that root 7. Let me just do this. Bring out root 7. So what will be left here will be negative 4, because when you are bringing it out, you are simply saying root 7 divided by root this divided by, so the 7 will cancel this. What will be left is negative 4. So you leave negative 4 minus, then this is another one, root 7 divided by another root 7. This will cancel out, you have 1, so you have 1 here. You see, so you are going to have root 7 into negative 5. So, and what this means is root 7 is multiplying negative 5. Just like I told you, because they are not similar and they are not like terms, so it will only come to appear in front. It will not multiply it and turn it to negative 30, root 35. No, it's just going to be minus 5 root 7. Yeah, I believe we are understanding this. This is very, very important. I want us to please to see this expression. So we should not be having problem. I think when you factorize, it's going to give you a clearer view. Let's quickly see another one. Maybe we have 2 root 3 minus, let's say 7 root 3. So what do? I can see the irrational part. So I bring it out. It's common. All right. So what will be left here will be 2. What will be left here will be 7. Okay. When you do this, you are going to have root 3 into negative 5. So what you're going to have is minus 5 root 3. You see, it's very simple. There is no big deal about it. So I believe with this, we should be able to handle questions on operation of sorts. All right, thank you for watching our video. Please like, share, and subscribe. And please stay tuned to our channel as we bring more videos on to you regarding different topics in mathematics. Even chemistry and physics will be having is going to be made available to us. Thank you for watching. See you in our next video. Thank you.